What about transition metals if we're trying to name things? And what if they have more than one charge? How do we do with that? Well, actually, one time I was at the Statue of Liberty. I saw this nice green color, asked somebody what the green color was, and the guy said copper chloride, and I knew he was wrong for a couple of reasons. So let's talk about names to formulas with transition metals. So the green stuff on the Statue of Liberty, copper chloride, is that the right name? Not really. If we look at the periodic table, chloride is going to be -1. All these are -1. Copper, though, can be +1 or +2. We don't know which one. So one of the things that we have to do is to make sure that we can somehow figure that out. And in this case, if we look at the formula, if chloride is -1 in this first one, and there's one copper, copper has to be +1. Here, if there's two chlorides and each one is -1, copper has to be +2. Now, what that means then is that in the naming, we have to give it what I call a middle initial. The middle initial is a Roman numeral that tells us the charge on the single metal atom. So in this case, and again, the Roman numeral is the charge, it's not the number of metal atoms. So let's say we have copper 2 chloride. Well, what that means is that there's a copper with a +2 charge, a chloride with -1. So how many chlorides do we need? Well, we need 2, so it has to be CuCl2. So don't forget, if there's a transition metal, they live in the middle, they have a middle initial. The Roman numeral is the charge on the metal. Again, the charge on the metal, it is not the number of atoms, or number of metal atoms. Okay. So let's keep on going. Let's see if we can try this one. Okay, so what would be chromium 4 oxide? Well, chromium, if it's got a Roman numeral 4, that means there's a +4 charge on a single chromium. Oxide is always -2. Again, look in the periodic table. And we need 2 of those O's to balance out one chromium. Lo and behold, it's CrO2. So remember, even though this says 4 right here, it's the charge, it is not the number of chromiums. So what I'd like you to do now is stop the video, write these down, give me the names, and don't forget, I'll give you a big hint, these are all transition metals. They're all going to have Roman numerals. Okay, now we want to go from formulas to names. And in this case, there's a couple of big ideas. First, you do everything you did before. Second, find out where the elements live in the periodic table. If it's a transition metal, and it's not one of the exceptions, you're gonna need a Roman numeral that tells the charge on the metal. How do you find the charge on the metal? You want to look at the non-metal first. Okay, so here's an example. Let's do Fe2O3. So if we write that out, we'll find iron and oxygen on the periodic table. And when we do that, lo and behold, iron could be +2 or +3. Lives in the middle. It's a transition metal. We know we're going to need a Roman numeral. Oxygen is always -2. So if we go back, oxygen's -2. I have 3 of those. Okay, 3 oxygens are going to add up to a -6. That means all of these irons has to be a +6. Well, I've got 2 of those. If I have 2 of those, each one must be a +3. We've just found the Roman numeral, which is the middle initial. Therefore, it is iron 3 oxide. Again, the 3 stands for the charge on the metal atom, which is the transition metal. Finally, last but not least, let's give this one a name. Okay, so here we go. It's lead, or PbCl2. Almost gave it away there for you. Same as before, we don't know what the Pb is. If you look, it's a transition metal. It could have more than one charge, and we know it's positive. Cl's the chloride, okay, so we know those are always -1, and there's 2 of them there. That gives us a total charge of -2. The lead has to be +2, and there's only 1 of them, so therefore it has to be lead 2 chloride. Okay, now it's your turn. Basically, stop the video, write these down. SnCl4, FeO, MnO2, and that's NiI, capital I, which is iodine. A little bit of a hint there, 5. Thanks a lot. Have a great night.